Section 3.2, solving systems of equations using substitution and elimination. We're doing the same exact thing with the systems of equations, except we're going to use algebra in two methods, substitution and elimination. So, substitution. Let's say we had two equations. We had x plus 2y equals 8, and we had 1/2 x minus y equals 18. Now, instead of solving for y and graphing them, we are going to use substitution, because sometimes when we graph and the dot lands or the intersection lands on a point that's not exact, it's hard to tell the difference. But when we use algebra, we can actually have an exact answer. So the first thing we do in substitution, step 1, is get one variable alone. That's just getting it all by itself. Now it's really easy for this top equation to get x by itself by subtracting 2y. So we have x equals negative 2y plus 8. Now this is what x equals. And we're going to substitute what x is into the other equation and replace for x. So that's going to look like this. We always use parentheses because we have to distribute the 1/2. And then I write everything else. Now this entire thing just substituted for x. Now my goal is to get y alone, so I just do algebra. First I'm going to take half of each of those in the parentheses. Then I'm going to combine my y's. Then I'm going to subtract 4. And then divide by negative 2. My y is going to be negative 7. Once I get, or step 2 was do the substitution. And then step 3 is to take that and substitute it right back in there. So solve for the other variable. So I'm going to show you that right here. X equals negative 2 times the negative 7 that we got plus 8. So that's 14 plus 8, which is 22. Now that we have both of those, my step 4 is write as an ordered pair. So my x would be 22 and my y would be negative 7. You can also see that that would get pretty confusing graphing because we would have to have the x coordinate go all the way out to 22. And sometimes we don't think about that when we graph. That's the first method of substitution. The second method is elimination. Let's say we had an example, 4a plus 2b equals 15, and a plus b equals 3.5. Now, for elimination, our step 1 is to get either variable to match up. Now, when I say match up, I mean the exact same thing needs to be said for both of those. Now, I'm going to try to get these two to match up. Now, this is just a 1, so in order to get them to match exactly, I have to multiply the whole second equation by 2. So what I'm going to do is rewrite the top, and I'm going to multiply everything on the bottom by 2. That way, those two match up. And you could have done it for the A also. I just chose the B. Now we're going to eliminate these variables. And by eliminating, we have to subtract the entire two equations. If I subtract the 2b from the 2b, they go away, and that's exactly what I wanted. Then I can solve for a. I have to do that to every single part. 4a minus 2a is 2a. 15 minus 7 is 8. Then I simply solve for the variable. So I get them to match up, and then the step 2 would be eliminate 1 by either adding or subtracting. In this case I subtracted because they were the exact same thing. If the signs were opposite, then I would add to get them by themselves. Step 3, solve for the variable. And step 4, substitute. Just like we did up here. When we got negative 7 by itself, we substituted into one equation. I have a equals 4, so I'm going to substitute in one equation. 4 times 4 plus 2b equals 15, and get b by itself. 16 plus 2b equals 15 minus 16. 2b equals negative 1, b equals negative 1/2. As soon as I get them both together, I write as an ordered pair, alphabetically, so the a would come first, and the negative 1/2 would come second. And that would be my answer.